Okay, for our next talk, I'm very pleased to be able to introduce a great friend, Dr. David Cassandra Mertz. David has written several books. He's been a director of the PSF. And he gave me this quote to introduce himself, which I think is appropriate. A certificate tells me that I was born. I repudiate this certificate. I am not a poet, but a poem that is being written, even if it looks like a subject. So I'd like to welcome David Mertz to the stage, whose intellectual hubris is only exceeded by his intellectual prowess.
Well, thank you, everyone, and welcome so much to PyCon MEA. I am delighted that this event is going on. Hopefully my computer will start. I want it up there. So this is going to be a technical talk, and therefore it's going to look like this. It'll look slightly different, but everything you're going to see is in the terminal. I'm talking to developers. Let me get it ready to go. So these are my faculty graphics introducing me. I'm not going to, Michael already said plenty about titles. I have similar background and experience in titles as many of the other speakers have indicated. But what I really want to say at the beginning, before I talk about what I'm talking about, is really to give thanks to the community. Marlene quoted a thing that Brett Cannon, another Python core contributor and director and things like that, that he came for the language, he stayed for the community. And so many of the people, my fellow speakers here, almost everybody that was listed on the slides that various people gave are people I know, people that I feel are friends of mine. And even those that I've never met them, the things that they have contributed in terms of software are just incredibly wonderful. And they've made my life so much better. And I'm just enormously thankful for that. And more than that, I want to say that all of you, even those who maybe you're just getting started in programming, or maybe you're just getting started with Python, please join us. Make the same community. Become, part of this community. This doesn't necessarily entirely relate to the rest of what I'm talking about, but I have to put this for Marlene, another wonderful friend that I made during this trip. But also because my slides are going to be not slides, but in fact very minimal. I've taken things away from them. What I'm going to be talking about is Python annotations. I assume many of you have used these, and you've used these perhaps with static analysis tools. Probably somewhat fewer of you have used these as runtime uses of annotations. Some of what I'll be talking about will be thanks to the wonderful work that Sebastian, who spoke today, has done as well. Others won't, but I want to go through this process that I went through in preparing this presentation of taking a look at a little program. I wrote a little tool a million years ago that I find a little bit useful. It's not big. It's not a million-line program. It's a couple hundred-line program. But it does something more than hello world. And I did it long before annotations were even a thing. And so I decided, how will annotations apply to this? And how will that work in combination with some of the different static analysis tools? And how can we take advantage of actual runtime use of annotations in this particular tool? So this is a live demo, but I'm cheating a little bit in that I've sort of given myself instructions, which you can take as the headers of my slides. So let me go ahead and run this. This is generally the tool. It is a command line tool. The purpose here is I want to find in a large collection of files that are in some directory with nested subdirectories, those that are duplicates. And there's a variety of ways they could be duplicates. They could be complete copies, and that's still worth knowing. Maybe you want to optimize disk space or identify redundancy, but maybe they're hard links. Maybe they're soft links. And I'd like to do this, and I'd also like to do this with the minimum amount of work I can in this little script. So I could run this. I use Conda often for environment management and package installation. It's a great tool from Anaconda. But in particular, it installs many libraries, but it is smart that it often uses hard links and soft links to save disk space in the allocation on disk. So I'm actually just going to show you what I already ran because it takes 30 seconds or a minute or something to run. But when I ran this, I see that I had examined 153,000 files, and it consisted of 42,000 and some duplicate sets. In particular, in the course of doing this, I had performed a number of SHA hashes, which is the way that I use to identify the identity of files in the content. 59,000 is notably fewer than 153,000. There are also a certain number of hard links that were found. It did a variety of things here. This particular tool is not the thing I'm talking about. It's just something that's of realistic complexity where we're going to benefit from annotations. But I want to show you, just for a moment, something about what the output of this tool looks like. When I actually do this, this is some number of 42,000 lines, I guess, or 42,000 sets that were identified. But I see that in some cases, such as on line 1, there are a particular collection of files that have that particular SHA hash. So those are all identical content. And you can see that in a couple cases, they're soft links. And there's an arrow that indicates that I'm annotating soft links in that way. You could imagine processing this file in some downstream way if you wanted. But if you take a look at line 10, you see that in some cases, I find these duplicates, but I avoid needing to do the hash operation. I just find that these different files have the same inode on my disk, so I can skip that extra work of doing a SHA, which is a fairly expensive operation. Let me show you just really, really quickly what the sort of basic pre-annotated version of the tool looks like. I don't want to walk through all the logic of it, of course. There's quite a bit that's going on. But it's much like a lot of Python code that many of you have written. I import a variety of things. In particular, I use a name tuple to store some information about each of these files I might be looking at. It has a main. It parses some parameters that are optional. It has a scan files function that will look through the file system and record information about it. There's a file called hash content, which is pretty straightforwardly just call the SHA-1 function that comes with Python. There's also a parallel hash function where if I have many cores available, I might as well use all of them to perform a hash at the same time, and ultimately that's going to go quicker if I do that. There's a couple support functions. This group by key I use a couple times. In the one case, if things have the same size, if they have the same SHA. It's a general utility function. It's the sort of thing that's a good support for this. And there's a few other functions that go into this. It wasn't big, but you got an idea of what the overall script is doing. One of the things you noticed about it was there were no annotations in it. As I said, I wrote this more than 10 years ago, before annotations were even a feature of Python. Let me do one more thing and just show you against a much smaller directory. So over pandemic, I wrote a book called Cleaning Data for Effective Data Science, which you should buy, but also you can find freely on GitHub, and there's a web page for it, and so on. I hope people enjoy it. But it has a lot fewer files inside of it than the Miniconda collection of the different libraries I've installed. I'm going to use this just as a sort of common sense check to make sure that as I make changes to this file, we really do keep producing the same result. So nothing changes when I do the annotations in terms of the functionality of the thing. This is not a complete check, obviously. But if I'm checking the same number of files and finding the same number of duplicates and the output is the exact same number of lines and characters, probably things are still working right. In real life, go write real unit tests before you change things. But let's ask a couple questions. Let's first see what MyPy, probably the most popular static type analysis, does when I give it this initial file, which, remember, has no annotations inside of it. And in this case, MyPy is always going to say it's happy. It's never going to complain because it doesn't know how to. It only looks at things that are annotated and does some static analysis based on the things that you've explicitly declared. There are a couple other static analyzers. One of them is PyType, which was produced by Google, but of course it's open source as well. It does a little bit more. It actually does some analysis of the the kind of the parsing structure, and it does static analysis of the implied types, even when things aren't actually typed explicitly. So this maybe is going to say something. It's actually not in this particular case. It's doing a little more. It's going to take just an extra little moment. But there was nothing wrong that it could detect in my original version of the program. I have one more to try, though. Here's another tool called Pyrite, and it's similar in a sense. It does somewhat different techniques than MyPy or PyType do, but it tends to be very aggressive in diagnosing anything that is in any way questionable about a program. So let's try running that one as well. I've sort of given the spoiler already that it's going to find a couple things to complain about. So this doesn't like two things in my original program. This is my untouched 10-year-old program. It doesn't like line 30, where the strip operator, the strip method is used, and it doesn't like the star, the multiplication operator, that's going to be on line 176. So I want to take a look at those lines and talk just for a moment about why it doesn't like those. So 30, 176. Well, the thing on line 30, I honestly don't understand why the tool is complaining about this. This may be somewhat unusual what I'm doing, but as part of my help screen that I'm displaying, I'm taking the doc string of the file. The doc string, of course, is the thing that's in quotes at the very beginning of the script file, and Python internally puts that into this dunder method called doc, and it's there, and it should be available. Now, maybe it's complaining because in concept, the doc string could be null, or none, rather, but in this case, it's clearly not, so this is a rather spurious complaint that PyType is coming up with. But let's take a look at 176, which it didn't jump to. Now, this is an interesting one. I totally didn't think about this until I started to develop this talk, and I used the program for 10 years, maybe 15, long time. And it's actually right here. Technically, the function in the OS module, CPU count, can return none. I don't think I've ever worked on an operating system or a hardware platform where it does, but as documented, it is permitted to return none rather than an integer giving the number of cores. So in concept, that could be none, and none is not something I'm going to be able to multiply by 0.75. So that was actually kind of useful. Maybe I want to correct that. Oh, I did that. So let's go through and add some type annotations. Let me show you the first version of what I did. So the first thing I'm going to create is find dupes 2 instead of find dupes. Compare is just, it's a little alias, sort of a wrapper around color diff, and nothing very interesting there. But it's a way of looking at the changes that I've made. So there's a couple near the top. They're not that interesting. I'm adding an import of path-like because that's going to be part of the type annotation I'm going to use. I have to add to the import for multiprocessing because I want to use one of the actual types that are defined inside it. And from typing, I'm importing a variety of things. So some various things are going to be iterables and iterators and callables and so on like that. So those names are going to be available to me. And what I've done is I've gone through every one of the functions and added what I believe are pretty specific annotations about exactly what it is that I expect to return from those functions. It might be possible to be even more fine-tuned in some cases, but it's pretty specific. So in general, the things that I'm scanning files over, the various directories, are an iterable of either strings or, in general, path-like objects. I guess, I think in a later version, I added an annotation for ops. I should have done that before. Now, here's something that's wrong. And I actually did this inadvertently. I didn't mean to make this error when I first wrote this annotation. But once I noticed it, I left it in there because it's a nice check for the type checkers. So the problem here, you don't actually have the code that shows it, is what's being returned isn't actually a tuple of a string in one of these finfo name tuple objects, but rather it's a tuple of two strings because I'm taking just one attribute of that finfo. You know, that was a little cognitive glitch I made completely sincerely. I mean, I was trying to do the right thing and I made a mistake. But I also introduced down here for parallel hash another mistake, just to, you know, exercise the tools. So this word wrong in caps is an integer in this case, where really what it should be is a string for the signature of this function. But you can see that I'm defining a relatively nuanced signature, that this argument finfos is going to be a list of these finfo objects, and a pool is going to be a multiprocessor pool, and it's returning a list of tuples, which are wrong in this case, but a list of tuples. And then a variety of other functions, like just this, have relatively nuanced annotations describing the details of what the arguments and the return values might look like. There's a few more where I define things, but it's the same general idea. I'm being pretty specific. I'm not going to bother running this again in the interest of time. Well, okay, I'll run this one. I'm not going to run the later ones. The V is I'm being verbose. The L is I'm including the links that are inside files, or there are two files. And doing the WC is just to make sure that these various summary stats really are the same as you saw slightly earlier. So probably haven't messed anything up in my changes. But let's see what the static type checkers say at this point. Well, MyPy isn't doing so great. You saw that every single function was annotated, and there were two problems. One that I was very deliberate in making, one that I accidentally made but left in there. MyPy at this point is being a little too generous. We'll give PyType a try. And it complains, but it only complains about one thing. This is the thing, it's actually because it's doing type inference using the name int, which was that variable wrong that I had defined. But this is the right line number, and this is the problem in the definition of parallel hash, where I had said that I'm returning an int, but actually I'm returning I'm actually returning an finfo object, but I'm as part of the tuple, but I said I was returning an int. So that's definitely a problem, and it's done a good job of detecting that. We try Pywrite. Well, it still has that complaint on line 32 about the doc string and not being allowed to strip it. I'm not happy about that. I feel like that's still a spurious complaint. We've already talked about that. I don't need to more. The second complaint It does something more lexical than static analysis in the way it looks at it, but it's identified the same problem, where I claim to be returning a tuple of string and wrong. I'm actually returning a tuple of string and finfo. So these are telling me useful things that I want to do in correcting my program. Of course, the program runs correctly, but the type annotations are not quite right. And it's going to be easy to correct those problems. So I've just changed a couple of signatures. The diff here is quite small. I've got rid of the wrong thing altogether and actually returned the right kind of thing. I also corrected the error that none of the static type checking tools actually detected, but I knew it was there, so I went ahead and corrected it. In this corrected version, well, we already saw that MyPy didn't manage to identify any of the problems, which is a little disappointing, so it still doesn't with the corrected signatures. PyType made one complaint, and once we run that again, it's going to decide that I really did fix things. I did also fix the thing that none of the tools detected. And same story. I mean, the strip is spurious, and we're going to ignore that for this talk, but the thing that I actually corrected was corrected in my changes. So let's take a look at runtime. What I've done so far doesn't use Pydantic. It doesn't use any tools that take advantage of runtime typing. Pydantic is by far the most popular, the dominant one. There's a few other efforts that have done something in that direction, but that's what everybody uses. And let's take a look at what changes I need to make. So here I've actually changed several things in order to let Pydantic do its magic. Of course, I'm importing some stuff from Pydantic, the validation error, which is going to be the sensitive typing kind of thing. And I'm also importing from Pydantic the data class decorator. This is a work-alike for the built-in, the standard module data class, but it knows more about Pydantic itself. So the main thing I've done to change it to allow runtime typing is, rather than use this name tuple that's kind of generic, I've defined these Pydantic data classes that actually have attribute names that are the various types of things I'm dealing with. And I also, before I was just using a tuple of a couple different things like a string and an finfo object. In order to be more explicit in my typing, I've decided I actually want the digest and the finfo to be attributes of this overall hash record object. So I'm giving more structured definitions of the types that I'm using. What I've done there is I've changed some signatures. So for example, I'm explicitly returning from the hash content function a hash record object, and I'm constructing such an object within the body. But there is something interesting going on here in the middle. If I would happen to get an I/O error, that is, like I couldn't read the file on disk because it was a transient file system error, or it was a remote file system that I lost access to, or there was a permission issue perhaps, or something else was going on that would throw that I/O error, I would get to this except clause, and I would try to construct a hash record that's actually the wrong thing. The first argument is a string, so rather than this digest that I might use, that's great. But the second argument is this descriptive, documentation cannot read that file, which is actually itself going to be a string, not one of these finfo data classes. So here's another error that I, the programmer, know is an error. We're going to see in a moment that we're not going to get quite the complaint we'd like because we never actually see that during runtime. I mean, maybe I'll have a file system crash when I run this in a second, but most likely my file system's going to work in a few seconds. And I've changed a few other things correspondingly where the return values become these more composite, well-named types instead of generically tuples or things like that. There's a little bit more logic that changes in a similar way, but in general, it's just trying to make use of those data classes that were defined with Pydantic. We'll see in just a second. You can use the data class decorator in Pydantic. There's also a more common thing, which is to inherit from something called base model, which has pretty much the same behavior as decorating something as a data class, but the data class one's completely compatible with the Python data class, so it has that nice property. Just trust me, if I ran this again, it would produce the same numbers of files and lines of the output and stuff like that. But let's take a look now at what the static tools will tell us. And in fact, MyPy does well here. It saw that in that error case, in that IO error branch that I had constructed, and I had deliberately sort of constructed the hash record in the wrong way, MyPy is pretty useful there. I'm going to skip here running PyType and find and PyWrite. They'll actually identify that error, but then they also identify a whole bunch of spurious stuff where they don't quite play nicely enough with Pydantic. There is a Pydantic MyPy bridge module that makes them cooperate well. I don't know if there's anything quite the same for PyType and PyWrite, but on the other hand, I want to talk about the actual runtime stuff. So you'll see the real complaint, and you'll also see a bunch of spurious complaints if I were to run those. This is, of course, at GitHub. You can go do it yourself easily. Now, the problem is, I did want to run that one just to show you that it's not going to produce the runtime IO error or any other kind of error because I'm not hitting an IO error, most likely. So indeed, it runs. If there were an IO error, my disk went bad, then something else would happen. But I want to illustrate this runtime thing and why it can be really useful. So let's take a look at another file that I've constructed, and this takes advantage of much of the machinery, much of the support functionality that my command line tool utilizes. So in this other little script, I'm importing, pool is just multiprocessing pool, but I'm also importing the finfo object, the data class thing. I'm importing the parallel hash function, which is kind of useful. It will perform hashes simultaneously on many cores, but it'll also not perform the hashes if it turns out they belong to the same inode and I don't have to do it. So it, is sort of a better version of the Unix tool SHA-1 maybe, or SHA-1-sum. And validation error is something that's coming from Pydantic. So, this is conceivably a script I might want to write. Maybe I'm going to do that scan files, I don't know, somewhere else, or, batch it up, or do it on a network file system or something like that. And it might produce sets of these file groups where I'm trying to create the SHA-1 hash of a bunch of files, but doing it efficiently, skipping work that I don't need to actually do. And these processed file groups could look something like this. And this is the exact same structure that I'm actually using internally in the main command line tool. So the first group of files, which as you can see is just the sort of versions of the script that I'm showing you, the inodes aren't accurate. They're actually from a different machine, but it doesn't matter for this purpose. There's some sizes of the different things. There's the names of the files. In fact, all the sizes are different, so I know they're not going to be the same. And the problem here, though, is in the second group. The first and the third group are, nice structures to describe the files that I want to do this hashing on. The middle one has a problem in that findoops 2a, I wasn't able to discern the inode, or the program I used to extract that information into these structures was, broken in some way. So I wound up with a none inside that rather than an actual inode integer. So that's bad. Now, if I were to use MyPy or one of the other tools to analyze this statically, it would probably say, okay, this is just a bad script. It has this problem in it. Don't do that. But very often what you want to do is as much of the work as you can and only remediate the things that you really need to remediate. So I go through, I look through the various file groups. I create these various finfo objects. but I catch this validation error. If something goes wrong at the sort of pedantic checking, type checking level, I'll do a friendly message instead, or do some other action to remediate the problem. And you can see that happens. I perform the various SHA hashes, but for the middle group of files, one of them didn't have the proper data inside of it, and that was a typing question. It wasn't just a, SHA failed to run for some reason or something like that. It was that for the attribute inode, none is not an allowed value. So this is a helpful message, but even better, it's a helpful message that I could analyze within the script to figure out what the appropriate course for remediation was. So this is sort of the example I have. It's relative to a rather simple program, but I think it's really quite useful to have this kind of type checking at runtime. Let me show you something I could do within the shell, but it'll be quicker just to show you the results that I had done before. So I could open up a Python shell and type this, and I would get exactly what you see on screen. Pydantic has this attitude where it wants to coerce types wherever it's straightforward and reasonable to do that. So this is a simple example, and it's using, in this case, it's the finfo that I'm inheriting from base model rather than creating as a data class, but the behavior is essentially the same. It's not important in that distinction. And it has a size and a path, which are nicely data typed, and an inode. And then I try to calculate this finfo object of a couple of these. These are, of course, just fictional paths. But the size attribute of the first is not an integer. It's an approximation of pi. But we still see that it decides, OK, a floating point isn't an integer, but I know at a type level that what you want is an integer, so I'm just going to give you an integer. I mean, it's a truncation. It's the same as if you would call the int function on the floating point number. And obviously, in the second example, I actually did give it an integer, so it didn't have to do any such thing. And so now I'm going to do a little bit of Sebastian's talk, perhaps talking slightly more slowly and with a little less sophistication, but I'm going to leverage this same tool/library that I've been talking about because I need this to be a microservice now, not just a command I run on the command line. And I've done it. It's running on my machine. I have UVacorn running in the background in another terminal, and it's when I change the file that's the main app, it's going to reload things. So the first one I'm going to do is the hello.py. So I just copy it to main.py within a couple milliseconds or something. That's the one that's actually running. And this one is basically probably the test case that Sebastian wrote for his documentation, or something very close to it. It's nothing very interesting. Well, it is interesting because it's a great library and it illustrates what the library is doing. But this is just something that you call this, it returns the message hello world. So there's no type checking going on here yet, actually. But let's try calling that just to see how it works. JQ is a great tool if people have to work with JSON. It parses it and makes it pretty and adds colors and things like that. And you can filter in all kinds of complex ways. But again, that's not the topic of this talk. So we see that I'm getting this JSON object back that just has this message hello world. So that's a great little web server to do something very simple. Of course, maybe I want my web server to do a little bit more. In particular, I want it to do a little bit more that actually starts to do something with types. I guess at this point I could be displaying main too, because I just copied it. We get a little bit of typing here. We still have the hello world route, or the root route, which produces hello world. But we also have this other path where we're getting an item and we're passing in an ID. And that ID in particular in the signature of the function is going to be an integer. And it's just going to spit back that integer, but as part of a JSON object. So we can call that as well. I guess I can still type this. I'm thinking of whether I should cut and paste rather than type, but it's more impressive if I type, right? So wonderful. We managed to get back a JSON object that had that ID number inside of it. What if we pass something which is, perfectly valid as a URL, but it is not in fact an integer as part of the query string? And we get a really nice descriptive. Am I out of time? Okay, I guess I'm out of time. I have to yield control. No, actually, I'm sorry. I'm going to take one more minute. So this is the next version, though. Let's say I've copied my Pydantic, my base models, this finfo and hash record that I was using in the other things, and I actually want to use those in the definitions of the route. So the route is going to be something that, takes one of these complex JSON objects, or a JSON object that matches the same as the data class or the base model, and then pass some various things to it, like that, which, because I'm out of time, I won't actually type. But the point is that if I do the right thing, it will return the right kind of result. If I do something that's sort of kind of right, but not quite, like using 3.14 rather than an actual integer, it'll still do the right thing by coercing the type. But if I pass something completely wrong, it'll produce the very same kind of type diagnosis error that you had seen earlier. But no more time, so I'm not going to actually show you the example. You have to go to the GitHub page and find it. Am I allowed to answer any questions, or?
I think we've got time for a few questions. Thank you very much, David.
Thank you all.